Hello, welcome to another installation of TechTalk. Is that TechTalk or TechTalk? I don't know, Mike.
Did you say Tim Tam or Tim Talk? Tim Talk.
Yeah.
The subject today, we're talking about materials. We're living in a material world, and I am a material boy. So different gloss levels that can be achieved, materials that are going into mixes. So trying to achieve certain gloss levels, and we can only deal with what we're given in a sense when it comes to different mixes and that sort of thing. It's definitely an interesting topic, guys. What's some of the things that we could be dealing with? Tim, special guest. Why don't you kick it off? What are your thoughts when it comes to different materials?
We're talking about ingredients, and we're talking about a finished material, aren't we?
Yeah.
And if we go back to the original definition of concrete, it comes out of a word that means to grow together. So concrete's very much a combination of different materials, and we know that our process is a combination of different materials as well. So we're talking about combination with combination, layers upon layers.
Getting too deep. It's getting too deep for me.
We need to try and understand a few of those layers, don't we? And look, I think everyone's seen the sorts of effects that we're talking about where, we rock up to some sites and we get fantastic results really quickly, and others we really got to work hard at it. So trying to understand some of those different elements, and I think we're all still learning very much about those things on a daily basis. So what are some of the basic composition products in concrete, guys, that may actually have some kind of influence on what we actually want from them?
Cement. I got it.
Sand.
Aggregates, stone.
Daniel stole my one, I was going to say.
Sometimes you see cigarette butts in concrete or piece of timber.
Pieces of plastic chair.
Fly ash.
Footprints.
Nails.
Rust.
Sometimes the odd Italian business partner.
Gee, you guys are giving a lot to work with this morning. I know how this slab's going to come up without even starting a machine on it.
Well, it's one of those unique trades that, if you're going to an existing slab that's been poured a few years ago, where the materials are actually provided to you. So for you to then meet somebody else's expectation, we've got to be real about it and understand what's in the mix, and not think all things are polishable, right?
You're raising a good point there, Milan. Often concrete, it's a case of the right hand not knowing the left hand's doing, right? People have all these weird, wonderful ideas of what makes good concrete, but they often don't have any idea of how that might affect what we're trying to do with it. If we look at the main ingredients, things like our aggregates and our coarse fine materials, or our larger coarse materials in the fines of the concrete, we look at things like the different additives, the different plasticizers and polymers and so forth that are put in concretes to achieve different outcomes. Cement reducing agents, all these different things that people throw in for often really good ideas, and sometimes they're just an idea, and sometimes they've actually got some really good fundamental truth behind them when it comes to the integrity of the material that's being made. But we're supposed to deal with all of those different things, and I guess we're trying to understand how some of them may affect the outcome of what we're doing, because we're obviously adding additional materials and products into the process on top of that. So for these things to be able to come together and grow together, they need to work together, right?
Correct.
And I guess from our side of things, our two main components that we're bringing to the equation are diamond tools and chemicals, right? So they're our tools that we're trying to actually manipulate or influence the material we're working with, right? So we need to understand how our two main interactions with the material can affect or be affected by what's actually in the material. Does that make sense?
Yeah. I have a question for you, Tim. Often we get contractors, they go to a project, they grind the concrete back and they start polishing, and they get to say 400 universal, which is where our first stage of polishing. We generally expect the floor to really, start showing its true colours and a bit of gloss at that point. And some contractors, the feedback we get is that at 400, this floor's not really looking that great, in particular the aggregate. Why is it that some floors at that 400 level don't really kick off just yet, in particular in the aggregates?
Well, there's different types of aggregates, obviously. There's three main types of aggregate origin or stone origin. And for those of you that can remember back to your science classes, and most of us did them, Those three categories are what they call igneous rock, sedimentary, and metamorphic rock. So they are the main three families of all origins of rock. So your igneous rocks are your volcanic origin, so rock that's come from lava. Now we know very hot material comes from the Earth's core, spurts out and cools rapidly in the environment. Okay, so they're your igneous or your volcanic origin. Now they're typically your hardest type materials, right? And we know that hard materials often start that way. Think of molten, metal and so forth. We end up with some very hard materials, but we've got to get them to a molten stage first. Then you've got your sedimentary, which is your layers of silt and layers of mud over time, okay? They're generally very soft and brittle and have very low compressive strength. And then you have your metamorphic, which is rocks that change over time. And in those types of categories, you've got your marbles and your limestone type aggregates. They all have very different properties. Obviously, the properties that we are really looking for is things like, I guess, density and chemical stability, or as far as its reactiveness is concerned. So we don't actually really want rocks reacting chemically with things. We want stability in our aggregates. So the actual origin of the aggregate, and therefore its compressive or its hardness, its density, is going to influence. So if you're using, say, a marble type material or a highly calcium-based material like limestone, which they have some great aesthetic properties, particularly in slab forms for bench tops and things like that. But as far as a hardness of material, they're quite actually soft. So when it comes to polishing, we're going to see a very different effect of our diamond tools on a soft material than we are going to be on a more high strength, high density type rock like your granite and your quartzes and things like that, okay? Why are we seeing it at things like at 400s and so forth? Well, look, I guess we're often starting to see a lot of reflectivity around that point in our process, okay? So that's where our contractors are really going to notice the difference of whether we're getting good reflectivity off the aggregate or whether we're not, okay? Because that's when it starts becoming really apparent to the eye and what we actually see visually. And I guess we have to start thinking about what creates reflectivity, and that's the uniformity of the reflection of light. So as a light beam comes down to a surface and bounces off, the more it bounces off in one way, the more it reflects, and therefore the more reflective it looks. And therefore we get a lot more light coming from that piece of aggregate to our eye, and we get not just the look of reflection, but we get the look of colour, because colour comes in those same wavelengths, okay? So it comes down to really the scratch profile that's in that particular aggregate, okay? Now, I know we cover in our seminars scratches and how scratches actually work and how scratches are created by diamond tools. Now, a lot of people think in terms of scratches is in terms of well, they need to remember that a scratch is both width and depth. So you can have a diamond tool that is not wearing so well, and therefore the diamond is not poking out so far. You'll still get a reasonably consistent width to your scratch, but not so much your depth, if that makes sense. Whereas if you've got a diamond tool that's wearing really well, you'll get the same width of scratch, but a much deeper scratch. Does that make sense?
Yep.
So if we keep in mind that when we're talking in our resins, in our 100s, in our 200s and 400s and so forth, we're still creating scratches in the floor. If that tool's working quite aggressively into a softer material, like a softer aggregate,
Marble or so. Yep.
Marble and so forth, a 400 scratch is actually going to be deeper in that material than it's going to be in a piece of granite, right?
Right.
So that could be one reason why that product or that aggregate doesn't look as glossy at that stage as it would, say, in a high quartzite type aggregate like a quartz or a granite aggregate.
So it has less resistance to abrasion.
Absolutely, yep. We also know that, we can get really nice shiny surfaces on certain metamorphic rocks, your marbles and your limestones and so forth. But if anyone understands the actual polishing process of those types of materials when they do them, say, at a fabrication factory, they don't finish just with a diamond tool. They're using a a polishing compound and so forth, often a compound that has like an oxalic acid into it, which actually creates a chemical reaction on the surface to give it that final shine, that final closing, or that final pop, okay? We're not introducing that type of compounds in our polishing process. So if you've got those soft, limestoney, high calcium marble type aggregates, it's very rare that we're going to get that really high, crisp, glassy look to them, because let's go back to the original industries they're used in. They've been using oxalic acids and polishing compounds for forever to get that final crisp shine. So that's not actually putting a scratch in it anymore. That's actually creating a different chemical reaction on the surface of the stone, right? So there's a few different things that are going on from our diamond tool point of view, but there are also other systems and processes that could be done to that particular piece of stone that are pretty impractical in our application, because that oxalic acid and so forth is going to have other implications on our matrix surrounding the aggregate. We're sort of trying to get the best out of a bad situation. All right. Does that make a little bit of sense into why we might be getting a bit of a different result in aggregates?
Well, I've got one there, Tim, because the interesting thing is we had recently a seminar, and I didn't get the wow factor.
That's it. Whoa. That's it. That's all we've got time for. That's it. We're going to have to continue this next week.
What do you mean?
That's it. Liam says that's time. He says it's time.
You're cutting us off.
He says it's time. All right. We have to come back and finish this next week.
You told me it was just 1 week, though.
Yeah, no, only paying you for one.
Do we have to do like a costume change, or can we just...
No. You can change your costume if you want to, Mike, but...
We'll just change the topic.
No, same topic. Yo!
Just too much information to fit into one day. So next week.
Yeah.
I'm hearing it. Hit pause on that. Don't grab a beer. Oh, you can grab a beer. Intermission.
Yeah, intermission. Hold that thought for 1 week. We'll be back.
All right, guys.
All right, till then.
Have a fantastic one. Enjoy that weekend.
See you later.
See you guys.
See ya.